Hello and welcome. I'm Alexander Muhidinov and we're going to create great things with custom PCG functions. I use them already in my game HitTube and I want to share some of them with you. First, we're going to create randomization. As you can see, in the main menu of my game we can randomize trees. We can randomize the amount of trees and locations of trees. We can do that with any mesh we want actually, so it's super useful for any game. We're going to create enemy spawns. With our code, we'll tell PCG what we want to spawn and how many we want to spawn. We can place these enemy spawns anywhere we want and they will work. And then we're going to use all our knowledge to create a dungeon. When we enter a room in the dungeon, the light turns on, and when we leave the room, the light turns off. So as you see, we start with simple tasks and then they'll become increasingly difficult. Our main goal in this video is to learn how to use custom PCG functions in a practical way, so we get knowledge and we make something ready to implement into your game. This is quite an advanced topic, but I'll try to explain everything in detail. Before we start, make sure that we have plugin PCG turned on, then restart your Unreal Engine. Also, since we're making a game and we have to always think about optimization, we won't turn on other plugins. PCG Geometry Script or PCG Biomes are great, but we're only going to need one plugin for what we're going to do, and we will accomplish a lot in a short time. In our first task, we're going to learn how to create our first custom PCG, and it will serve as good practice before creating our dungeon. Our first task is create spline of meshes with random seed. Let's check out my game HitTube. I made trees with PCG, but I want to randomize them each time player opens this level. I like almost everything, water splashes are great, but I don't want to see the same trees over and over again. To make it happen, let's open modeling mode. We want to create a spline, but I don't want to screw up the location of points. So I'm going to change the view mode. I added a tag because it's very important for our upcoming PCG. PCG is going to fight our spline because of that tag. It's very important how we name things in this video. After we create a PCG, we open it. We create a spline and we want to get data from spline. So we create node get spline data. We search all world actors. With the tag trees. After selecting the node, we press D, which stands for debugging. Now we can see temporary cubes that show us how the debugged node works. We create a few more nodes. And I want to mention the static mesh spawner is great compared to spawn actor, which is costly. Let's select any static mesh, we just need to make it work. Meshes are not important. can also add self-running node. It's used to optimize and refine the distribution of points by removing points that are too close to each other based on a specific distance. Let's create blueprint for our PCG. Our blueprint is going to change seed. But I already have a blueprint. And it's called PCG updated seed. Create an asset just like I did and name it in the same way. It won't have output pin seed for now. We're going to add it soon. In this type of blueprints, we don't create construct function or create even begin play. We usually create either execute function or execute with context function by pressing override. As you see, we have instance editable variable seed for dungeon. We need it so we don't create the same PCG blueprint over and over again. It is instance editable. We can tick it on and off in our PCG graph. We also have local variables. As you know, variables are containers of information, and local variables are more optimized than usual ones. But they work only in one function, and if we remove them, we won't give a warning that our local variable is connected to something, so be careful. We created a branch because sometimes we need different types of seeds. Then we create attribute set because we needed to add attribute data to the collection. And we create mutate metadata to create and set new attribute. Below, we can change the type of variable. We can make it a boolean, float, integer. Then we add it to collection, which is important because we change data and we have to give in the end new data, otherwise it won't work. Don't make a mistake with the attribute name, otherwise it won't work properly. There are also custom functions. We can change the color and rename the node. Great. The first custom PCG works. Press and compile, you refresh the results. You also can update the results in PCG graph. want to explain something about extremely important thing in generation trigger. We have three options for generation. Generate on load. We compiled, and now it will be always in the level just like that. Generate on demand, it means it's going to generate only when we force to do it in our blueprints. Let me show you an example. But there is a better option in our case, since I don't want to use any nodes and I want to generate something new every time I open the main menu. So I choose generate at runtime. It's going to load always new seed. If you stay on generate on load, the same values will be over and over again. We don't want it. So I pick generate at runtime, and now I always have a new seed for trees. Well done finishing the first section. Now you're going to get questions and practical tests. Don't skip them. They'll help you remember everything that you've learned and get better at PCG. If you are unsure of an answer, then just rewatch this section. Have fun and good luck. Being prepared to create the dungeon. The next task is a bit more difficult, but it's important for our dungeon. Let's create a new PCG graph. Small optimization, as always, removes unnecessary pins. Place our PCG on the level and change the scale. Get actor data self means it will spawn just where we placed our PCG. Volume sampler will help us to control the amount of NPCs. If volume sampler is too small, then it won't spawn anything. Spawn points will give some randomization in rotation and location and scale. You can use for now spawn actor and pick some actor in template actor class, although in the next section we'll give it a random PCG function. But for now let's stick to spawn actor. Let's give random seed from our custom PCG function that we made in the previous section. If we place it on a level, we have to always pay attention what size we have. The bigger PCG, the bigger amount of NPCs. Be careful though, if it's too big, Unreal can freeze. Voxel size changes the number of actors too, but it's more important thing than usual scale. I want to create a few more nodes for our PCG to change the voxel size. Integer will have different value. Also, we're going to need another editable value with branch. Now let's randomize it. I gave it not correct values, now it will be my mistake. I gave it not correct values. Now it will be much better. Now it's random enough. So now you decide you want it on demand or on runtime. In the next section we will improve this PCG graph. And of course we want to add navigation mesh, so AI will be able to move. As you see, everything works perfectly. To remember everything I've explained, try to answer this question. I'll see you in the next section. Here we are, the most fun and difficult part of PCG. We're going to create our first dungeon using custom PCG nodes. I developed a dungeon room. You can create your own room too. Just remember that the size of that room is the usual size of Unreal Engine's cube. If you want fast results, just use Unreal Engine's cube. I imported the static mesh that I created. Created blueprint class, created light and empty PCG graph by pressing the button Add. The lighting works, but our rooms should be dark before we enter them, so we're going to set the intensity to 0. As you know, the closer light, the bigger shadows, so don't place the light too close. If we enter to our dungeon room, nothing will happen, so we have to detect our player. We press on box component, then we create overlap events. Now we create basic blueprints. Player pawn 0 means first player. We either have on in world settings, or first player possesses an actor and it becomes player pawn. Dependency can have other values, it just depends on your projects. Since we trigger only once, we're going to use the node do once. We can create it by pressing Alt, then left mouse button on our graph. Although it will be much better if we are not going to use these nodes. We can set up a PCG graph that we created in our previous. Pick the PCG graph that we created and remove these blueprint nodes. The generate node will use our PCG, and the PCG in this blueprint is on demand, which is exactly what we want. I want more randomization, so we'll create a switch on integer, and this room will be able to spawn either NPCs or weapons. Weapons will spawn in the middle of the box. I added two more nodes for our PCG and wrote inside of them specific name my actor. Also I changed spawn actor too. What I did is super cool because now we're able to change actor from our blueprint. We don't create input or output pin, we just used a PCG node to get it from our blueprint class. All we need to do now is create a variable inside of our blueprint class with the same name myActor and change it to actor class because I want to change classes. Now our NPC can be either zombie or friendly human. Let's make it editable. we did it. If you put a player in a room, it's going to spawn NPC or weapon. Now we have to make the dungeon. Create another PCG asset, then place it on this level and open the PCG. Create point grids, create points in the middle. Let's add transform points and change the scale. Press D on transform points. Cell size, change size of each mesh or actor. We're not going to need that. Grid extends changes along each axis, which determines how many of them spawn. We need this one. We either place it manually or with custom PCG function. Let's randomize some points, because not all rooms in dungeons should be the same. We need to create select points. Ratio 1 means all points stay the same. Ratio 0 means all points will disappear. Let's speed things up a bit. It's all the nodes we need for our dungeon. We change grid with specific value of random seed, and we use male vector attribute to avoid changes in the z-axis. Otherwise, our dungeon will have a few floors. Then we use the difference node. We take all points from our first node, create points grid, and compare it to select points. And the points which are empty now have static mesh spawner, different type of rooms. In my case, it's just a blocker. By default, PCG removes collisions from static mesh spawners. We need to select static mesh spawner and pick lock all. Now collisions go. Now let's create one more blueprint node. PCG dungeon rooms. We created function execute with context instead of execute, because execute with context has context, which we need for point loop. Context contains all information useful for an operation. It contains all input and output data, pointer to PCG component that is calling us, the target actor, etc. We need getType input by pin label to make it work with input node in. Then we get all point data and make it into point loop, after which we create local data, so our function won't work. And we connect this local variable to our return node. Now what's the point loop function do? This function will loop through all the points inside of the PCG point. Now what point loop function do? This function will loop through all the points inside the PCG point structure and it spawn meshes how we want. Don't forget to tick on return node, otherwise it won't work. So with this I made random rotation for each room and random seed. But each dungeon room of mine looks exactly the same on each side, so it's not really visible. To make it visible, I'll change rotation a bit in other axis. Now if we delete directional lighting, we get lighting like this, and everything spawns just the way we want. But AI can be stuck in the air. There are two reasons for that. First, make sure you have placed in bold or spawned of this NPC. Second, make sure you added enough mesh bounce volume. Since our PCG appeared after the level is launched, we have to make our nav mesh movable in project settings. Just like that. Now everything works, NPC can move, they can spawn, and they can attack. Our main goal, just like I stated in the beginning of the video, was to learn how to use custom PCG functions. And you did it. Good job. That's it, we did it. I appreciate you being here. Before finishing the video, I want to sum up everything what we have learned and give you a few more questions.